Welcome today for this tutorial. I want to show you how to make a circuit for controlling street light using a sensor, LDR, light dependent resistor. This project is very crucial and is applicable in so many fields, especially in dimmer switches, motor control, and power circuit regulations, among others. So it is very important to have the basic of this particular project. I hope you will enjoy when you begin up to the end. We have got components. One of them is the light dependent resistor, and this is it. The second one, we have the BT136. So it is the same one, but here this other one we have anchored the heat sink onto it because it produces a lot of heat, and that heat needs to be dissipated into the environment. That's why we have used the heat sink in order to dissipate that heat into the environment. We also have resistor of 150 kilo ohms. We have our soldering gun, which we are going to use in solder. We have the solder wire, and we have a few connecting wires. We also have a bulb, and its bulb holder. So these are the requirements needed in this particular project. So I want to draw for you the circuit system of this particular project, for you to know how everything shall be moving in and out. So this is our circuit. This will be our negative. Remember, this will be our bulb. This will be our live. This will be our neutral. So this will be our light dependent resistor. In short, LDR. This will be our fixed resistor. I've said 150k, and this one will be our BT 136. This will be the bulb. I've said this is the negative, the neutral, and this other one is the live for our circuit. Let's begin. So we want to mount our BT 136. You mount it facing you. It has got a flat surface. This other side is flat, this other side is not flat, so the unflattened surface should be facing at you. Right? So you simply need to solder. Yes. So we have soldered the BT 136. We want to create extension of these outer terminals of the BT 136, that is the anode and the gate. Yes. This is just an extension because we want to align the terminals, and these terminals are closely held together. So we want to spread the outer terminals to create space. Do the same on the opposite side. That's it. Then we take our light dependent resistor. Make sure that one terminal of the light dependent resistor is in line with our extended terminals of the BT136. As you can see, they are in line. Yes, this shows that the current which shall be flowing from our LDR will pass through the gate terminal of the BT136 and will circulate through the anode terminal of the BT136 and will flow back to our LDR. After that, we have our fixed resistor. Make sure that one terminal of the fixed resistor is placed in line with the cathode, and the other terminal is fixed in line with the previous terminals of the BT136 and the LDR. Then we solder. Yeah. So this will be limiting the flow of voltage into one BT136 MOSFET. So up to that extent, we are almost over. We move to our terminals. We have our negative terminal or the power source. This is our negative terminal of the power source. Negative terminal of the power source. And we connect it to one terminal Yes. So we have connected it to our negative terminal of the LDR. This is the LDR, light dependent resistor. This is the negative terminal of our power supply. Then the positive terminal of our bulb, we connect it. The negative terminal of our bulb, we connect it to the negative terminal of the power supply. Then the remaining terminal of our bulb, we connect it in our circuit. Sorry. At that point, then we solder. Yes, our circuit is complete. As you can have a look of it. So I've said this is the positive terminal of our lighting system, our bulb. This one. And this one is the negative terminal. So you want to have a test to see how lighting occurs. Let's take a test what that we have done. Is that correct? Is accurate? And now when our LDR, light dependent resistor, detects light, detects darkness, it cuts off the flow of voltage, flow of current, and therefore the bulb goes off. And this is how it happens. You can see when the shadows comes in, the brightness of our bulb goes down. So the shadow and the brightness of the bulb are directly proportional. As you can see. Okay. Now it goes until it's off. Then when I remove the hand, the light increase until it is now more brighter. Let's repeat again for you to see. The light is reducing until it is off. And when I remove the darkness, the light increases until it becomes enormous. Thank you so much for watching. I hope you have learned and you have gained skill in this particular field. This particular project is applicable in a variety of projects in real life. One, as I have counted some of them before, it's the one, the principle is applicable in making and calibrating our lifts, such that you get that no one can be pushed or may be injured by a lift while entering the lift. Once you try to enter the lift and you stand in between the doors, then it will stop, it won't get into contact. That is a principle which we are building up in this particular system. So there are several projects in real life where this principle is applicable. I wish you can purchase some of these components we have used and do it by yourself. You will gain enormous skill and knowledge that you will use in the real life situation. It is also applicable in conveyor belt, whereby in automation, whereby the sensor in a conveyor belt will detect the shadow of the object, then it will stop until that object is loaded into the conveyor. It will automatically begin to move into another stage. It is a very, very important project to those who wish to work in industries, automation, instrumentation and control, electrical, electronic, and the rest. Thank you, feel welcome. Don't forget to subscribe to our channel. Thank you again.